All right, section 4.5, we're still talking about triangles, and we're still talking about congruent triangles. Again, I copied and pasted these two triangles, so they are congruent to each other, but let's just pretend you don't know that I copied and pasted it. Can you just tell, looking at it right now with that information, that they're congruent to each other? No, you couldn't say it. Now, they may look like it, but you can't just go by the looks, can you? You got to go by the information. So far, we've learned two different ways to prove triangles congruent. You may want to keep a little running list here. Okay, what's the first way we learn how to prove triangles congruent? Side, side, side. Okay, what's the second way? My S's are crazy looking. And then side, angle, side. What must, if I can say this right, what needs to be true about this angle? Is it just any side and any angle, or what? This angle has to be what? Say it. This angle has to be what to these two sides? We said it yesterday. Think what you're saying. In the middle, okay, watch. If I was given this side and this side right here, okay, could I have an angle right here? No. Is that side angle side? No. There's two sides and an angle. That's two sides and an angle, right? It's got to be in between them. Thank you very much, okay? Joelle was listening. It's got to be the included angle. All right, it's got to be the included angle. So which angle? It must be that one right there, okay? So if I'm given these two sides, I must know that this angle, okay, I don't care about this one or this one. That's not going to help me prove the triangle is congruent. We don't have a side-side angle theorem, all right? We talked about that yesterday. All right, we don't have a side-side angle, but we do have a side, angle, side. You with me? All right, that's just a review from yesterday. Let's get rid of this. Now, they could give you some different information. And I'm not going to go through like really an explanation of why. We could. These are actually, this is still a postulate. Remember, these are all postulates, and the next one we're going to do is also a postulate. So we can't really prove it. You just have to accept it as being true. So here's another situation. If I gave you this angle is equal to this angle, is that enough to prove the triangle's congruent? No. What if I said that this angle is equal to this angle? Is that enough to prove the triangle's congruent? Nope, not at all. All right, because watch. Let me just show you. I could do this. I don't know if this will work or not. Look at this. And I took this arc right there and put it right there. Would you agree that's the same angle as this? And this right here is the same angle as this? Are they congruent triangles just because those two angles are equal? No. Christian, you asked me earlier, do you have an angle, angle, angle theorem? Well, do you? There is an angle, angle, angle? If three angles of this triangle are equal to the three angles of this triangle, does that make the triangles congruent?
No.
Look at them. Do they look congruent at all? No, I made it pretty obvious. They're absolutely not congruent to each other. Just because the angles are all equal to each other, you know, from one triangle to another, does not mean the triangles are congruent. You've got to have something about the sides, all right? Now, the shape is the same, right? The shape is the same. All the angles are the same, but this is definitely not congruent to this. Agreed? Yes, no, you don't agree, or you do? Okay. All right, let's go back to this. So here we go. We got our two triangles right here. I've got two angles right here. If I gave you this side and this side, I'm telling you right now, that's enough. That's enough to say that the triangles are congruent. Because watch, if I did this, if I took this triangle and I said, hey, let's shrink it down. But what did I just do to that? Is this side right here the same as this length? No, the angles are the same, but I changed the side, didn't I? So if this side has to stay the same as this, and these two angles on the outside of them have to stay the same, then those two triangles are going to be congruent. Remember I talked about giving you like straws or sticks or something like that yesterday? If I gave you one length and one length right here, and I'm like, okay, here's two other lengths. I'm not even going to tell you what the other lengths are, but the angles have to be the same. This angle has to be the same as this, and this one has to be the same as this one. And I told you to draw a triangle, right, or make a triangle with that. Everybody would get the same exact triangle, right? Nobody could get a different triangle. Everybody would get the same looking triangle. If I said that this one has to be the same as this, and the other two sides have to make the same angle with this side, you would get the same exact triangle. So what do you think we call this now? We've had side, 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 angle, side. What do you think we could call this? Very good. Angle, side, angle. That's exactly right. So we say it, what? Angle, side, angle. But how do we write it? That's right. We write ASA. All right? So we say angle, side, angle. But we write it ASA. All right? So there's another way. So let's add that to our list. Angle, side, angle. So we've got side, 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 angle, side, angle, side, angle. All right? We use it just the way that we use the other stuff. Okay? If I give you some information, if I'm given these two sides, what do I say about that side? This side is the what side? Joelle, you said this earlier. This side has to be what to these angles? It's got to be the included side. This has to be the included side, which means it's in between those two equal angles. You got it? Does that make sense? So, yeah. In order to have angle, side, angle, this side has to be in between those two right there. Now watch this. Do you remember we talked about this? This was some time ago. If I have two angles equaling to two angles, what must be true about this third angle up here? We had a theorem. We even named the theorem and everything else. You guys don't remember? We talked about this, I promise you. If I have two angles, remember, how many degrees did all these angles add up to be? 180. Okay, let's just make something up. That looks pretty steep. Let's say that's 70 and that's 50. All right? Might not be, but that's okay. If that's 70 and that's 50, what's this angle up here going to be? That's 120, right? So this has got to be 60. Would you agree? Now watch. If I said this angle is equal to this, what's this angle then? What's this one? Okay, now watch. 70 and 50 is 120. Take it away from 180. What's this have to be? This has got to be 60, right? I wasn't given that these two were equal, was I? I was given that these two and these two are equal. But watch. If I have two angles of one triangle equaling two angles of another triangle, what must be true about this third angle? You guys aren't listening at all, are you? I can see it. I'm saying stuff, and this is what I'm looking at. I'm looking at heads are all moving around, looking all over the place. Come on, you got to focus a little bit. All right, let's pay attention. It's not that hard. If these two angles are equal to these two angles, what must be true about the third angle? They got to be equal to each other. They got to be the same. These have to be equal to each other as well. It's called the third angle theorem. Don't you remember that? Right? The third angle theorem. Look it up. All right? We talked about that. Look it on YouTube. We've discussed it. All right? You guys act like you weren't here at all. Were you? Yeah. We did this, didn't we? Didn't we talk about that? Sure. So watch. If these two angles are equal to these two angles, that must mean that this one is equal to this one. All right? You with me on that? This is going to help us out a little bit. Watch. This gives us another theorem. Look at this. What do I have here? I got two angles and a not included side this time, don't I? Watch. This one and this one equals this one and this one. You got to watch where I'm pointing, because if you don't watch, all of thises and that's aren't going to make sense to you, okay? These two angles right here are equal to these two angles right here. This is a non-included angle, so that actually gives us another. This is a theorem this time. These are all postulates. That's right. These are all postulates, which means they don't have to be proven. This one, after we figured out that these two are equal to each other, like, hey, wait a minute. What if I had two angles and a non-included side? Right? Let's say I didn't even know anything about this angle right here and this angle right here. Okay? What if I didn't know that? What if all I knew was this information, that these two and this non-included side? You're like, well, is that enough information? Well, it is, because watch. If these two are equal, what must be true about this angle and this angle? They got to be equal too. So you could always say side or angle side angle, couldn't you? But instead of going that route, we could say, hey, wait a minute. Instead of talking about that third angle, let's just say these two angles are equal to these two. This is a non-included side. So that's enough. That's enough to prove that the triangles are congruent. So what do we call that? Angle, angle, side. All right? So now you got how many ways to prove triangles congruent? 4. You got 4 of them. So when they give you a couple triangles and they give you some information and you have to figure out why are those triangles congruent to each other, you've got 4 things to choose from, right? And it's not just guessing, is it? It shouldn't be. You shouldn't just be guessing on what triangles are congruent. Right, and that's what you have to do. So let's do an example, okay? Let's do a quick little example here of the kind of stuff you're going to see on the worksheet. Okay, we're going to write this thing down. It's going to look like a proof, but it's not necessarily proof. Actually, let me pause this. I'll write it, and then I'll come back to it. All right, here's our picture. Oh, I forgot to put the points here. Let's do that real quick. So P, S, R, and Q. All right, this is what I want you to do. You don't have to go through a whole entire proof, but this is what I want you to do. I want you to mark the stuff on the picture first. It says QS, line segment QS. That's this one right here. It bisects angle PQR. Where's PQR? PQR. It's that big one right here. Now watch. If it bisects it, it cuts it into two equal angles, right? The angles would be the same. So this angle would equal this angle right here. Everybody see that? Okay, and that's what you would draw on your picture. So I want to see these arcs on your picture. All right, and where did you get that from? You got it from this, that QS bisects that angle. You with me so far? All right, let's look what else they say. Angle PSQ. Where is that? PSQ. That's this angle right here. Okay, it equals RSQ. So this angle here equals this one right here. So let's mark it. So that angle equals that one. So I want to see these marks on your picture. You got it? They don't tell you anything else, do they? But just looking at the picture, we can come up with something. And we did this a little earlier today.
Oh, angle side angle.
Okay, where'd you get that side?
The middle one.
The middle one. Give me the letter.
It's the bias.
Say it. Give me the name.
SQ.
Give me the name of the line. SQ.
SQ.
Right, SQ. So how do I show that SQ equals SQ? Put a little tick mark right in there, okay? Remember, SQ is shared by both those triangles, isn't it? SQ is in this top triangle right here, and SQ is also in this bottom triangle. You see it? So even though it's the same side, it's still a side on one triangle, and it's a side on another triangle. So I can say they're equal to each other. Now look, I've got an angle, I've got an included side, and I've got another angle. So are these triangles congruent to each other? Yes, they are. For what reason?
Angle side angle.
Angle, side, angle. So this is all I want you to do on this. I want you to mark the picture with what they tell you. Now look, they didn't come right out and say that this angle is equal to this angle, did they? They said it was being bisected. So you got to know something about bisecting, right? You got to know if it says it bisects an angle, that means it splits the angle into two equal angles. So you have to know that. Make sense? They tell you this straight up. That's the given. And you had to figure out. They didn't say anything about QS, did they? You had to look at it and say, wait a minute, it's shared by both of those. We actually have a reason for that, and it's called the reflexive property. I'm not going to make you write that down, but I think it's important to understand. Okay, it's called the reflexive property, why SQ is equal to SQ. That's the kind of stuff that you're going to be doing on tonight's homework, okay? So let me give you the worksheet, and then you can go.